We are given the functions f of x and g of x, and we have to determine the composite function fog of x as well as its domain, and as well as go of fx as well as its domain. So first let's find fog of x. So I write down fog of x. This is basically equivalent to f of g of x. We now replace g of x as given over here, that is 2x minus pi. So therefore this becomes f of 2x minus pi. And in the next step, we replace all x by 2x minus pi in f of x. So I take this f of x, replace the x in the numerator by 2x minus pi, over replace this x by 2x minus pi plus pi. So we will get this simplified. We will have the numerator 2x minus 5 divided by this negative 5 and positive 5 gets cancelled, and we will have over 2x. We can simplify this. So this equals 2x over 2x minus 5 over 2x. 2x over 2x basically 1. So we can rewrite this as 1 minus of 5 over 2x. So this is FOG of x. Now let's determine the domain of this composite function fog of x. For that, we have to look at the domain of the input function. This g of x is basically the input function for the composite function f of g of x. So we have to first see if there are any domain restriction for the input function. We have the input functions g of x equals 2x minus pi. This is basically a polynomial function, which means it is defined for all real numbers. So there are no domain restrictions on g of x. We then look at the domain of this composite functions and look for any restriction. Clearly, if you look at the composite function f of g of x, this 2x, we have x in the denominator, which means x cannot be equal to 0. So here x is defined for all real numbers, that is from negative infinity to plus infinity. And when we combine these two domain restrictions, we get the domain of the composite function. We can write down this as in interval notation as negative infinity to 0 union 0 to infinity. As we understand that x is not defined for 0. So this is how we write down the domain of the composite function in interval notation. We will now determine the composite function g of f of x, and as well as its domain. So first we write down the composite function g of f of x. So this can be written as g of f of x. And we now replace this f of x as given over here. So this becomes g of replacing f of x by x plus y. Now this is equivalent to replacing x in g of x by x over x plus y. So I'm going to replace this x by this expression x over x plus y. So therefore this becomes 2 times of x over x plus y minus 5. And we can simplify this. So this equals 2 times of x is 2x over x plus 5 minus 5. And to make common denominator, I'm going to multiply and divide this by x plus 5. So in the next step, I can rewrite this as this equals 2x over x plus 5. And we have to multiply this 5 with this expression, that is x plus 5. So therefore this becomes 5x plus 25 over x plus 5. We now have the common denominator x plus y, so we can combine these two rational expression. So therefore this becomes 2x, and we have to distribute this minus into the two terms inside the brackets. So it becomes 2x minus 5x minus 25 all over x plus 5. 2x minus 5x is negative 3x, and we have negative 25. So we can write down this as negative 3x minus 25 over x plus y. So this is basically the function g of f of x. Now let's determine the domain of this composite function g of f of x. So for that we have to consider the input function. Here the input function is f of x, that is x over x plus y. So we write down the input function f of x equals x over x plus y and look out for any domain restrictions of this input function. Clearly this denominator should not equal 0. So we write down x plus y not equal to 0. Solving this, we get x is not equal to negative 5. So this is the domain restriction on the input function. And for the composite function, we have the domain restriction. That is, this denominator should not equal 0. So we get x plus 5 not equal to 0. And this also gives x is not equal to negative 5. So in both domain restrictions, we get x is not equal to negative 5. So therefore, we can write down the domain of this composite function. That is, domain is in internal notation as uh, it is defined for all real numbers except negative 5. So we start from negative infinity and we end up with negative 5. That means that this negative 5 is not included, union, and then we start from negative infinity, I'm sorry, negative 5, and close it with positive infinity. So we write down this domain as like this. So this is the domain of the composite function in internal notation.